Hi, everyone. It's time to get started with the dispatch meeting. I'd like to thank Matt Miller for being our Jabber scribe and VJ and Pete for taking notes for us. Yes. Did we have the wrong thing on the screen?
Alrighty, so this is dispatch working group. If you don't want to be here about dispatch stuff, then time to go. Okay, here's the note well. You probably would have seen this more than once today. Oops, see, this thing is backwards. Okay, here we go. So we actually have very few things on dispatch this time. We have web transport. Victor's going to talk about that. And then we have several things in the art area that we're going to talk about. There's a new proposal called RIP. And then we're going to talk about, this will be a fun discussion, the BCP 190 applicability to trans. Okay, dispatch. Okay, so as a reminder, here are our IETF 106 deadlines. And again, we drive those. So hopefully there's a little bit of mailing list discussion before the meeting, right? So the BOF deadline is October 4th. October 7th, it's always good just to let us know that you're going to bring something forward so we can plan time. Because as you notice, we only got an hour slot this time because we didn't anticipate much. And of course, at the last minute, stuff came in. So it's always helpful to let us know ahead of time. All righty. Okay, and again, working with deadlines. If you make the deadlines, you're on the list. If you're not, then you kind of come towards, you know, if time allows, sort of thing. And again, it's helpful if you've got a dispatch item you want us to dispatch, to put dispatch in the name. It's a little bit easier to find in the tracker, and there is a way. Again, there was a ticket open. I should follow up on that and whether or not you can do a replaces from the document. And any questions, contact the chairs. Mailing list. So for general discussion of art topics, it's art@ietf.org, and then for actual work that you want to move forward, dispatch@ietf.org. Okay, Victor? Okay, and I'll give you the thing to drive.
Right. Yeah, could you switch to the web transport slides? Yeah.
Yeah.
Hello, everyone. My name is Victor Vasiliev. I work for Google. I worked on Quick and TLS before, but today I'm going to talk about new works that I want to bring to IETF called web transport.
I was going to say, yeah, you need to write it. I was wondering, nice microphones. Off the staff.
Okay. Is this better? All right. I'm Victor Vasiliev. I worked on TLS and Quick. I want to talk about web transport, which is the new work I want to bring to IETF that is currently already in consideration in W3C Web Incubation Community Group. So just to introduce you to the problem, so web applications traditionally used only HTTP as a transport. HTTP is a response request protocol, means that you will only get traffic from server if you send a request first. Around 2010, people realized this is a problem, so we introduced a protocol called WebSocket, which allows to speak subject to security constrained, arbitrary TCP traffic, but it runs over TCP, so it's reliable, ordered, and that is enough for some applications, but not for others. Around sometime later, we introduced a new API called RTC Data Channel, which is a peer-to-peer DTLS over HTTP, and it has an API which is very similar to WebSockets, except your messages can be marked as sent and received out of order or marked as unreliable in general. RTC Data Channel is inherently peer-to-peer, which means you need, it's designed to communication between browsers and peers which might be behind NAT. So it doesn't, you can fit into, into the use case of talking client to server, and there are special provisions in those standards called iSlide, which is a way to use data channel in client-server setting. But in practice, it doesn't work that well, and I've had conversations with many developers. I'll talk later about which doesn't work as well. So this leaves us with a gap, feature gap, that we want something that is client-server like WebSockets, but supports unreliable or unordered delivery. And the proposals I'm going to talk about is called Web Transport, and it adds effectively just that. So why would you want something like this? And the answer is for many years, people have been asking browser developers to add something that's roughly like WebSockets, but for UDP. It's been a repeated request, and we've reached out to some of those people, and there are a wide variety of use cases where you'd want that, but the two main use cases is one, there are lots of people who want this for online video games, because video games traditionally are latency sensitive. And the second wide use case is people really want this for live streaming, especially live streaming with low latency. And the proposal we have is called Web Transport. Web Transport is it's not one protocol, but it's a framework for making protocols which are usable on the web, and you can use them interchangeably. So the idea is, if you have a transport protocol which provides streams and datagrams, streams, by streams I mean streams which are like quick streams, or like an individual TCP connection, ordered streams of bytes, potentially bidirectional or unidirectional. And datagrams, when I say datagrams, I mean things which are shaped like UDP datagrams, but in order to be compatible with Web Transport, the transport protocol has to be subject to multiple security constraints, which are outlined in the draft, but notably your transport has to be end-to-end encrypted. You have to support CLRS, you have to support origin checks, and you have to make sure continuously that your protocol is, that your server is still willing to talk to you. And those are requirements will be familiar, especially to those who work with data channels, because those are essentially similar, very similar requirements. So when I say protocol framework, originally this was one protocol called Quick Transport. But eventually people brought up that Quick is not always usable, and it would be really bad for us to just fail hard if Quick is blocked in the network. So we defined a family of protocols which are usable interchangeably, and one of them is called Quick Transport, and Quick Transport is very similar to WebSocket. I'll talk about differences, but Quick Transport is basically WebSocket over Quick. Fallback Transport is a simulation of that semantics, but over TCP for cases when Quick is blocked. And HTTP-free transport is probably most interesting here and most complex. It allows you to create streams and send datagrams within existing HTTP connections. And this is particularly useful if because if you have an existing connection, it allows you bypass congestion control slow start and establishment latency. But it also comes with all limitations that now you're sharing your connection with other traffic. So just to elaborate on what are exactly properties of Quick Transport compared to data channel, first, like obviously one of them is peer-to-peer, another is direct. And we do a bunch of, we remove a lot of things from the model of data channel, which makes it easier for the common case of client server. For instance, in data channel, you have to provide the certificates of both peers out of band in order to establish trust between two parties. And in Quick Transport, you just use WebPKI, similar to WebSockets. We don't have to use eyes. You have a slightly different, and I would say richer model of communications in data channels, and most notably, you don't have to use user space as CTP, you have to use Quick, and this is on some level really important, because one of the feedbacks we got from the developers who we were talking about why they don't use data channels, especially in context of web games, is that a lot of them complained about complexity of implementing entire RTC data channel stack, and FTTP was noted as a particular pain point. Even on top of WebSocket, we do bring a lot of improvements, which are not just like the obvious improvement of unreliable unordered delivery. For instance, we no longer have the WebSocket masking protocol, which was added for plain text WebSockets, and we don't have to use it because we encrypt all traffic by default.
Would that were true, if you're doing TLS as opposed to Quick as your underlying substrate, then and you're using a stream cipher like RC4 or GCM, and the attacker can produce essentially any bit pattern he wants on the wire by simply exfilling the keys from one side to the other, and then producing counter masking or flipped plain text. So if the extent to which you think this is a problem, it is still potentially a problem.
You mean a problem on Quick and both Quick and TLS?
It wouldn't be with Quick because Quick, but remember that. So the reason the masking exists in the first place is because they're intercepting proxies that would intercept TCP, take things that look like HTTP, and then get confused. And if your underlying substrate is TLS over TCP, then you still have potentially the same problem.
Interesting.
I don't know if you do, and the situation may have improved intercepting proxies because it was quite some time ago, but I'm just not entirely convinced it's not a problem.
Yeah, so this is definitely something we'll have to think in more
It's not
detail.
a big deal either way.
The other thing is that WebSockets involve a special SHA-1 based handshake in headers, and we use the fact that in Quick, enforcing ALPN is mandatory, so we rely on ALPN to avoid cross-protocol attacks. And other improvement is, unlike WebSockets, we do not ship cookies or any credentials by default, and assumes that the application has to communicate this explicitly, which I believe is a good improvement of the privacy and security surface of the protocol. That's basically the overview of the protocol. There are lots of details I could go over, but I want to hear what people here think about this.
You've heard me ask this before, but now we're in a bigger arena. So partial reliability.
Can people please say names when you go to
Sorry, Roberto Payon, Facebook. So if we want to do these things for real-time communication, often that means skipping past something that has consumed some part of the offset space because it's no longer relevant to the application. So being able to read things piecemeal, or at least being able to bias towards the most recent data, is an important aspect. Thanks.
So, Martin Thompson, I'm tentatively supportive of this this notion. I do recognize that the sort of space of partial reliability or unreliable transport from a client-server perspective is really, really awkward when you're forced to use WebRTC. And there's some opportunities here to use Quick more, providing fallbacks to HTTP and WebSockets and all those sorts of other things that we have. There's a bunch of complexity here with respect to getting the APIs right so that works. So I think that whatever work we do here will need to be closely coordinated with the groups in the W3C that if they decide to take up the work, we'll have to negotiate that one.
Yeah, this is definitely, there is a lot of API discussion to be had, and fortunately, I think two of the editors are their own.
I saw Peter working on
and Bernard, as I think, is on the,
Bernard's
yeah.
there. I did want to add to Eka's point, though. It's not just TCP that suffers from this problem. If you were able to know the keys and absent some difficulty with getting the packetization right, you could predict the ciphertext of something and therefore influence the ciphertext of something. You could make a UDP packet look a lot like a DNS packet. And there's a bunch of networks out there that look at DNS packets and produce responses. I don't know what you do with that, but it's just food for thought. There's some work to be done there.
Justin Uberti, Google. Just sort of speaking from the RQC standpoint, I think you could probably make all this stuff work with data channels, but we are definitely hearing the same thing, that it's just really, really difficult. People are having to hand roll their server stacks. If we had had Quick available to us, built in DTLS 1.3, 8 years ago, we might have made some different choices. I think this is going to be really useful, and people will flock to it.
Jana Iyengar. I'm going to try and keep this short because my voice isn't cooperating. So I like the direction that you're talking about. I'm not sick, Ecker, you can sit. I am not. This reminds me of a discussion we've had before, though, and I want to raise the question of, is there anything beyond an API in this? Partly because the protocol mechanisms, partial reliability, we're talking about as a feature here, for example, or as a service that gets offered up through this API, is ultimately going to have to be built into a protocol. It'll be quick, and then you'd have to figure out the protocol mechanisms necessary for building it into quick. And then it gets surfaced up. And this reminds me exactly of a discussion we had a while ago, and that turned into a working group called TAPS. And that's part of my I'm trying to figure out how to square this away with that conversation. And Tommy here is saying it is TAPS. And that's sort of where I am in my head. And it's not clear to me what the difference between this and TAPS is.
Are you asking difference between this and TAPS?
The difference between this and TAPS, or more generally, what is there in here beyond just an API? And I say just not because it's simple, but what's there to do here beyond building an API?
So quick transport requires some wire changes for stuff like origin checks, but those are relatively simple. HTTP free transport requires some things to fit arbitrary data into HTTP free, and those have to be well defined. So that's the wire part, and this is a major part of why we're bringing it here. Because if it was just simply an API, it would have been to some extent out of scope of IETF, but this requires a lot of work on how to figure out the wire protocol. Yeah.
So I'll be quick. Ecker, are you chairing this thing?
Okay, let's be quick because we've got a long line here.
Fair enough. So I was saying that this is, if you can specify the requirements and then they turn into protocol building units, that's fine. But web transport itself is simply an API. The rest of it goes into working groups, I think.
Okay, Colin, would you mind if I let Bernard in before you?
Oh, please do.
Okay, Bernard, I'm pushing the red button. Okay, you're on, Bernard. Are you?
Speak, Bernard.
If you're speaking, Bernard, you're muted.
Can you hear me now?
Yes.
All right. So I just had a couple of questions from a security point of view about the difference between the HTTP3 transport and the quick transport. Are they equivalently secure? It seems to me the HTTP3 version can inherit some of the things from WebSockets, cores, all that stuff. Is there, and also potentially fallback with the issues that Ecker raised potentially there. The quick transport just uses an IP address and a port. doesn't need, I guess, much in the way of protocol work, but from a security point of view. Could you comment on that? Is there differences in the security requirements and functionality? Also, the functionality seems pretty similar, right? You can do everything in the HTTP3 that you can do in the quick transport, is that right?
Basically, yeah. In terms of security requirements, I believe like there are slightly different threat models, but with HTTP3 transport, you have to watch out for like once you are allowed to create streams within a connection, you have to make sure that you do not create too many streams and eat up all the flow control window from regular HTTP traffic. But other than that, they all have require plenty of opt-in on both parties' sides, so I believe it should be safe from that perspective. And they both require TLS.
Yeah, so I guess basically to Ecker's point, those threats that Ecker talked about wouldn't exist in the quick transport, but they would in the HTTP3 with fallback, I guess. Is that right?
Probably. I'll need to think more, and I'll need to talk with Ecker more about this class of attacks.
Okay, thank you.
Colin Jennings. My comment is actually sure. I don't know whether this is exactly the right solution or not, or what the technical security deals are, but I think I have a real need for something like this, and it would be really useful to be able to do this. And using the whole WebRTC data channel stack is too difficult. It's a bar too high to reach, so we need something much simpler than that allows people to do it on the web end. I think we should proceed with something along these lines.
Ted Hardy, to talk about the dispatched question. I think this is a big enough piece of work that it needs a buff and a working group rather than being assigned to an existing working group or otherwise dispatched. Certainly, I don't think it's ready for AD sponsorship. And I will point out, for those of you who have very, very long memories, that when Quick was started, one of the things inside Google that was considered was just taking the WebRTC data channel spec and just making that real easy. You can see we didn't go there. We went somewhere else entirely. And I think we're at the risk of kind of coming back and making some of the same mistakes we made in RTC Web. For example, the WebSockets API imitation. Again, if we don't start with saying at above, here are the requirements that we're trying to meet, and here are the design spaces of APIs we might want. And I think that we may end up saying that what you end up wanting is Quick with some of the data channel capabilities built into Quick native rather than HTTP3 or WebSockets like models. And I would really like to start there rather than retrofitting. Thank you.
I agree that we need a specific list of requirements, and I actually have something like that list, but I didn't put this on the slides because of time constraints.
Wu from Facebook. So I really like the direction. So internally, we built some system to do the bi-direction communication based on HTTP2. We already put a draft on HTTP-BIS to discuss how we did that. Actually, we try to solve very similar problem in different problem space. Definitely, we should catch up.
Hi, Brian Trammell. +1 to it seems like there needs to be a bar for this and actually encouragement to put that together for Singapore. Like it seems like it's in actually pretty good shape to take there. I did have another, I got in line because I hadn't heard Jonna speak yet and say the word taps. So I wanted to come up and say the word taps.
The word taps was in original version, but we're aware of us tabs.
Okay,
like we're looking.
So I'd like to make a more specific sort of suggestion here. Specifically, you're looking at basically having this web transport run on top of 3 underlying potential transports, which have somewhat different contracts. One of the big differences between them is some of them are streamed and some of them are not. This is exactly sort of the kind of situation that the TAPS API was designed to look at. I would suggest having a look at least at the TAPS architecture. And if there's anything in the TAPS architecture that doesn't cover what you're trying to do, we would very much like to know about it in TAPS because we want to finish that by Singapore.
Yes, so the short answer is we believe that it would be useful to provide a TAPS-like capability match API for this.
Yes.
We do not want to actually bake it like on the raw browser API because it's kind of too high level compared to what we want. That's a short answer, but we've definitely considered, and this is something I wrote up. Yeah.
Let's talk a bit offline
Yep.
for the long answer.
All right.
Thanks.
Hi, I'm Seth Gentle. I've just gotten back off the weekend hanging out at DWeb, talking to a bunch of people working on DAT, working on IPFS, and a bunch of these other technologies. One of the big, the sentiment there is that WebRTC has not been useful for a lot of folks. They found a lot of difficulty in using WebRTC to build peer-to-peer systems, and hence the need for things like Beaker Browser to be able to actually add application level, like explicitly implement protocols like DAT in the browser because of a lack of more protocols like this. So I just want to say, like, as someone representing all of the folks that I talked to on the weekend, there's a lot of demand for more ways that we can do networking. So generally supportive. So cool.
So we are at about 5 minutes before the end of this discussion. So I would appreciate if people we've already had some comments about what do we do next, and comments in that direction would be highly appreciated.
Right. Two quick technical points, and then I'll talk about issue next. I guess one, I'm sort of cautiously optimistic about this. I'm vaguely sad that people seem so sad about data channels, but it seems to be the state of play. So there we are. Second, I don't think this will solve your DAT problem because it's explicit client-server mechanism, and so unfortunately, you're continuing to be sad about data channels. In terms of what we do next, this is clearly like way too big to just 80 sponsor or take two working group down. So I think like the right answer is BOF. So I would encourage you to ask for one in Singapore.
The line is kind of frozen, but unless, okay.
Ben Schwartz, Google. So could you clarify for me, is HTTP3 transport built on top of quick transport?
On top of quick transport? No, it's
I didn't think so. So is quick transport meant to be implemented by browsers?
Yes, quick transport is basically quick, but with origin field. That's the simplest way to describe it. And it's a very low-level primitive. It's very simple, and
but it's not a primitive that's used by HTTP3 transport.
Yes, in as much as like they both use quick, but that's it. That's yeah.
Okay, that's good to know. I just will say for my use cases, HTTP3 transport provides all the benefits that I would want out of quick transport. So I don't have a use case for quick transport, and it might be easier to dispatch without quick transport.
Yeah.
Roberto Peon, I remembered this time. I just wanted to really quickly say that I really dislike the idea of quick transport because I like the idea of having one protocol that I can dispatch. H3, for instance, because people have said, is that the same? Well, yes, but it's also a superset because HTTP implies caching. And caching is a way to get scalability, and that's a huge differentiator.
So the short answer is I've thought a lot about quick transport versus H3 transport, and I've talked to a lot of people, and depending on what you want to use it for, you will either really want one or other. Because quick transport is useful, for example, online games which just do exchange real-time stuff, and they don't want to have all H3 overhead. But you will obviously want H3 transport, and I understand why you don't need
I
other.
want both, and I think we can fix it by fixing HTTP, as opposed to trying to have raw sockets, which is terrible bad. We've seen it, it's bad, right? Let's make HTTP work really efficiently for these use cases, which may require some extensions there. Anyway, I'm done.
Martin, since you were heading for the mic, we have time for one more thing if you want to say it. Mic is frozen after Martin.
Martin Thompson, in terms of dispatching this, the W3C is obviously going to have to build an API in order to support this. I suggest that we simply respond to a request from them and then talk about creating a working group in that context. Now, it might mean that we wait to have the BOF until they make their decision, but it might also mean that we can skip the BOFing part. We have a liaison. We should continue that conversation with them. This is not going to happen on its own.
Correct.
So we need to sort that relationship out.
Okay, so, okay, our liaison is there.
Wendy's probably kicking around somewhere, and we have a liaison here. So.
Okay.
Okay, so what I've heard is that several people have expressed interest. Several people have expressed that this is something that would need to BOF, and we definitely need to coordinate with WC3 and figure out how to move forward on that.
Yeah, just before I go, there is a side meeting in which I want to go in like the finer points and like quick versus HTTP free transport, and that's on Tuesday at 3:20 p.m. Yeah, so that's all on my part.
Oh, no, give me, I need that. No, you leave that there. I need this. This is- Yeah, yes. Okay, so we're done with dispatch and we're gonna move to art area meeting. What is?
Are there
supposed to be I'm sorry. Okay, never mind, sorry. Wait, yes. What now, Paul?
Are there supposed to be separate blue sheets for the art area?
No, it's the same. It's a joint. But we split it. Okay. So can you do we do that? No, we're not. No. No, we're not. It's still cut off. It's still cut off. Okay. That and then the full screen, little thing there. What? No, it didn't do it. Okay, there we go. Okay. No? What is, okay. All righty. Okay, people, if you can be quiet, we're continuing the session here. So the BOFs, just to highlight BOFs that are going on, there is the MOPS BOF on Thursday, and this was related, if people remember, we had the GGIE topic. Oh, so how did, okay. Oh, okay, sorry about that. Someone messed up, probably me. And then there's the ad BOF, applications doing DNS. I didn't put when that was down, so people can look at their agenda. Side meetings, there's a side meeting, and Eric, I don't know if you want to say something really fast for international shaking, because I just went through and looked at side meetings and looked at ones that might be interesting, because people don't say if they're closed or general interest, so if you want a bunch of people there or don't want a bunch of people there, you might want to say something.
Well, so it's Eric Berger, and this is the IETF, so we're using an IETF room, so it's open.
Okay.
However, it's mostly going to be regulators and policymakers from various countries around the world. So if you're thinking this is where Jim and I are going to do a knockdown, drag out, steel cage match of international shaken, you'll be disappointed. But if you're interested in other countries other than the US and Canada adopting stir and shaken, then feel free to come. Although the room, I think, only seats 16. I didn't expect lots and lots of people to show. So
Okay.
send me emails if you do want to go.
Okay. And it's the Kohler room. I think it's Kohler and not Collier also, right?
We're in the coal mine. I don't know.
Okay. All righty. And then Victor already mentioned his web transport. I had a question after it because it had a question in the agenda, but it sounds like you're having it. You're on, right? Okay. Yep, it's on. And then there's an HTTP priorities thing in Van Horn. And again, I just pulled things that look like they might be interesting. So if someone wants to say 30 seconds on what that's about. Mr. Nottingham, is that yours, the HTTPS priorities? So I mean,
I can speak to that. We're trying to work out what to do with signaling of priorities in HTTP.
okay.
Did you get the Webpack one that's on tomorrow morning at 2?
Oh, okay, I missed that one.
So
Sorry.
just saw that go by an email. There's a web packaging side meeting. I don't know what time.
It's tomorrow morning.
Tomorrow morning.
Open session. Jeffrey, you want to say which room it's in?
It's in Van Horn, 8:30.
Okay, thanks. Yeah, and again, there's the link in there for where you can go look at all of them, because there may be others that you're interested in. Okay. Okay.
Okay, if there is something with the side meetings, you may remember that we are working on encryption for email so that users can actually use it, and there is a mailing list called Meetup, and we are now also having side meetings on the topic, and the next side meeting will be on Wednesday afternoon. I think it was 3:20 in the room up there in C2.
Okay, so
And
did you
one-
send it, okay, send an email to the,
I
yeah.
can send an email as well.
That would be good, yeah.
But one topic is like synchronization of private keys, which attract a lot of interest.
Okay. Okay, and then, oops, sorry. The new working groups I'm aware of is the BIMI, or however you say it.
Did we charter that while I was sleeping?
I thought,
This is
well,
Barry. No, I'm
okay, sorry,
quite certain
okay.
we do not have a BIMI work.
Oh, I thought I saw that one out there. Never mind, okay.
We have a RUM working group, which was chartered since
Oh, okay,
IETF
so maybe
104.
This is the fake news art
This is,
session.
Ben was too far from the microphone, but he said this is the fake news
Well, I
section.
guess I found I guess I found the charter and thought it was working.
Yeah,
That's what happened,
But
okay.
there's a working group called RUM that was.
Okay, that's fine then, okay, so that's.
chartered since
Yeah,
IETF
that's what I
104.
meant to type, yeah, yeah. About what, Eric? Oh, oh, right. Paul?
I can, but I don't know.
Just say 2 words. Please come.
2 words.
You're taking away from Colin's time, so you better talk
Yeah.
fast, so get on to you.
I don't even remember what the acronym is. Relay User Machine. Okay. It's basically discussing an interface for a graphical user device, primarily for the video relay services.
Please come. Okay.
Yeah, please come.
And before we get into the topics, there's just one thing that I wanted to say, and I don't know if Adam wants to say something as well. This is Barry Leva, Art AD. The ADs have currently asked the NOMCOM to fill 2 Art AD positions because Adam and Alexei are ending their terms this time. But we are having a meeting later this week, the Art ADs, about deciding whether we really want to fill 2 Art AD positions or just 1 and drop down to 2 ADs in the area. So we'll be figuring that out this week, and we'll let NOMCOM know our decision, and they'll let you know. Input to that would not be unwelcome.
So before we start this, the one thing I wanted to mention is that there is a group of people, and this was posted to the art list. I just wanted to make certain that everyone has noticed it. There is a group of people putting together a formal specification of the robots exclusion protocol, which you may know as robots.txt. My inclination at this point is to AD sponsor this. I think it would be a very, very good thing to have an RFC that formally defines this with modern BNF and all of the bells and whistles that come around that. If you have any concerns about that course of action, or if you want to give input to the document, please reach out and let us know. Thanks.
Okay, I'm going to be talking about this RIP stuff here for a second. So next slide, please. We're at a very early stage on this draft, okay? The authors don't even agree on what it should do. We're still sort of thinking about it. Much of the stuff that I see coming up that we discussed earlier today and some of the other sessions today just make me rethink that there's much better ways to do some of the things that are in here. So this is, I want you to get a feeling for the problem we're trying to solve, and we're trying to get a bunch of people to come and get their input, make sure we've got a variety of requirements into it, and it meets an interesting solution. And it is around the space of sending media in a more cloud-friendly way. So next slide, please. The problem that we've been looking at is we start building all of these cloud services, and they might have WebRTC coming up with them, and they typically needed to take a SIP trunk of some form to take some voice over to the PSTN, or maybe over to a voice recognition API or text-to-speech. There's a bunch of use cases. We'll talk about those in a minute. But SIP was not very friendly in the way that it worked in coming into large current cloud deployments. There's a lot of infrastructure that's been built for those that we can't particularly take advantage of. And this protocol that we're looking at is how can we do a better job of that, make it easier for us, make it easier for that type of connection to work. So where we're looking at this is, if you take WebEx going to or a cloud conferencing service, there's end users and the devices. They might be using WebRTC or something like that up to a cloud service, or who knows what they're using. It's a cloud service that's doing a bunch of processing. It inevitably has to do some SIP trunking today off to a service provider that'll connect it up to the PSTN. And what we're looking at is replacing that link, the top one on the green here, between the cloud service and the service provider. It's not about what goes down to the endpoints or any of those things. It's a cloud-to-cloud sort of thing that's less than 20 years old. It's a sort of modernized version of it. So next slide. So later on, I'm going to talk a little bit what the technical properties of this are, but we're going to run media over HTTP. We've had several discussions about that in various forms today of H3. And we're going to try and have a very simple replacement that gets rid of many of the problems that we've had with SIP, SDP, and RTP. And there's a lot of reasons we want to do this. The big ones are there are all kinds of services that were built for scaling large-scale websites. They're already out there. They're very easy to use. You're familiar with them. You've used them, like auto-scaling. I mean, load balancing is something that you can do in SIP. You could build all of this. Every one of these things you could build in SIP, but they're already built and deployed in an incredibly scalable way on every major cloud service. HA, we did it one way, assuming a certain sort of design in SIP. It's very hard to do high availability in a modern cloud world where various VMs will just be rebooted and things like that as part of the service. It wasn't, SIP wasn't designed quite for that type of high reliability. It was designed for a different type. So API gateways, being able to use those, being able to use all the modern web DOS prevention tools, service meshes, all the application monitoring. There is just an incredible amount of infrastructure that's been made for building these HTTP-based services. And we want to be able to take advantage of those in a really easy way. So that's where that's the design space that we're trying to deal with. Next slide. As I mentioned, this is a logical extension of people starting to move. We went into the WebRTC stuff. This moves the other chunk of it that was always out of scope for WebRTC, which was how do you do those cross-cloud links. Next slide. So I'm going to talk about a couple of the actual sort of use cases that are the driving this. Yes, next slide, please. One is the general telecom apps and bringing those into like a web PaaS type environment. So we're seeing more and more of those. You see companies like Twilio's, others, Google, there's all kinds that have various infrastructure for building these things, and how do we connect them together. The calling servicing and call centers and that type of area right now is in a large transition from being premise-based to being cloud-based. And as they move to that, they want to be able to use that. So the leading cloud call center providers are also trying to deal with that. If you're trying to embed those into your website, have a website that has easy chat, it's very common to see WebRTC used for that now, to talk from your browser or your device up to the cloud service, but there's not a good way to get those cloud services down to the other parts of it. Next slide. SIP trunking, just basic connecting to the PSTN. You'll see, you might not think that that's a huge part, but I mean, like, keep in mind that is the profitable part of Skype, right? That is, a key part of every, whether it's Hangouts or WebEx or any of these call centers, is a very important part of all these systems is connectivity to that system. Even though people are largely IP-based, they still need the option to be able to do that for a certain percentage of their calls. It's a very painful part of doing it. Next slide. So I'm going to jump into give you a little bit of flavor of the way we're thinking about this problem. This is obviously very early and would change wildly in where we go. So next slide. The general information flow is you start thinking about what needs to go from one cloud to the other cloud. And it's really not very much information. And it's pretty simple in these cases, largely because they're constrained. And we're trying to currently constrain to just voice on PSTN interop, but expand out beyond voice later. So one thing that you need to know is, hey, what codecs and parameters does this other side support? And it's a very static thing. You can get from the service provider, we support the following things. That's it. It doesn't change on a call-by-call basis. It doesn't change on a day-by-day basis. It's a pretty static thing. Next, when you go to set up a call, you can say, set up a call like this. You don't need offer answer. Just ask the web community how much they love offer answer. And it says yes or no. That's how things work on the web, right? And it's very simple information what you could set up. It's just use this codec, this phone number, perhaps. Then we get some basic events back. There are very few handful of events that are of any interest to what's happening with a call. It's proceeding, it's ringing, it's ended, it failed. It's pretty simple. The media stuff is a little bit more, and then we need the media back and forth. And I think a lot of the sort of things I saw in MOPS today, early on and here today, there are different ways to do media. We've been doing it with the most brain dead technique that's been proven to work for a long time is multiple long poles over H3. And I'll talk a little bit about that later. Next slide, please. The capabilities of what we think that you should be able to describe is really in the codecs you support, max and min bit rates, size of samples, whether you need to force to use constant bit rate or not. Few other little things, but it's a very minimal set. When we went through everything that was in SDP and said, what parts of it do you actually need for this type of system? This is pretty much it. We throw it in a JSON document, like a JSON record, and call it a day. Next. Advertisements, what we need to do, numbered call, caller ID of the caller, which always brings big questions. Next slide. Lag here. We're going to use passport. Sounds really complicated. It's a JSON object with like 3 things in it, you know, who you called, who you're calling, the time, signed. Next slide. The protocol mappings of this, of how we map it into H3, there's just, you know, some various API calls that we hit. We hit a few to get to the things I've talked about, like getting the capacity, creating a new call. Once you have a call, you can basically poll for the events, and you basically set up a bunch of concurrent transactions for the forward and backwards media. Next slide. The basic media approach that I talked to is you at the beginning, you know, do a bunch of posts to set up these concurrent transactions for the media. And when the other side wants to send you some media, when it has the first RTP packet along, it sends that to you over the connection, and we mark that connection as in use, or that byway we call them. And until that is ACT, it's in use. And when the next RTP packet arrives, you would send it over a different byway until it was ACT. When the third one arrived, if the previous one was ACT, you could reuse it. So it's a very simple transaction. It has an ACK of every packet. There's many ways we could probably do better than this, and we can talk about how we want to hit those. Yeah, sure. Bernard, questions?
My comment is, I think it would be interesting to explore how this might be done within the web transport trial, which actually is real code, to see if it can be done better or if the changes are needed to make it more efficient. But this is exactly the kind of flow that was thought about there.
Yeah, so I totally agree, Bernard, and having watched the previous presentation, I'd love to try that. I know Justin also has some ideas and a lot of experience in data and various ways we could do this. So yeah. I think that this is one of the active areas.
No code, you can actually play with it and actually try it out and give feedback on it. Anyway.
Cool, we'll do it. Next slide. Yeah, no, I'm fine with that. That's our events. One more slide after this that we go with. The security is a really easy model with this too. It's all exactly how we do web security. There's no special encryption for the media, no special anything. It's just TLS for the one way. We OAuth with a token the other way. And it is not an end-to-end security model. This is a from the cloud provider over to the PSTN provider, okay? It's not trying to accomplish that. I think that's pretty much, one more slide, let me just, okay, we're done. So questions about this, and then I'm gonna make my ask for what I want people to do. So any questions about the sort of general space we're proposing and thinking about? Ronnie.
Ronnie Evan. I'm a bit confused because I don't understand what the relation between PSTN and all these codecs that you want to negotiate, because PSTN is G711, so what are we doing here? I don't understand the case here.
This is for a cloud service like WebEx to be able to have a very web-friendly way that runs in modern cloud centers to set up what we used to do with a SIP trunk over to a service provider that was providing us PSTN termination like Comcast.
Melzanati, when you say PSTN, you also include mobile network too, right? Not just just landline. So.
Yeah, sorry, I meant just my mistake in using the word PSTN. I understand your question now, Ronnie. I mean the existing pod. It's not even pods. I don't know. Whatever that thing is that use phone numbers.
Are you
I don't
talking
care about
about what we call, Eric Berger, are you calling what we call interconnected VoIP? Okay.
You know, like, I don't know how people make these SIP gateways and they connect to something, whatever's on the other side of that, like ISDN, SS7, you know, that shit.
Yeah, but the thing is 60% of the time it's SIP.
Yeah, and 60% of the time it's connected through a not SIP interface to get to SIP on the other side. So either way, I don't care. What I want to do is not think about the SIP. I want to think about the web stuff and not have to deal with all that crap. I don't want to worry about whether it's called VoIP, interconnected voice, mobile, or PSTN. Okay, so we're working this on GitHub. Super welcome comments on GitHub, PRs, any of those things. Love to work with people on that. Please let us know if you're willing to participate. If people are super interested in this, I have blocked off a room at 8:30 tomorrow morning where I'm glad to talk about it more, but really I think the best thing to do is just go get on GitHub and start hacking this forward and let us know what people need. So questions, comments on that?
Final comment, yeah.
Ben Kadek, I'm obligated to note, and I don't expect a response, but OAuth is a authorization protocol, and you have it as an authentication protocol on the slide.
That's really embarrassing. Thank you. What are those? I never want to know what those are again. And yes to early media, no to forking.
Well, they're right there. They're there. They're hanging out over to the left. Sorry, I'm trying to hold the slides up here. No?
Sorry, we got slides late. So let's see.
It's my bad. Oh, there you go, right there.
All right. Hello, my name is Devin O'Brien, and I'm with Google Chrome, and I'm here to talk about certificate transparency and BCP 190.
I think you can try that. It works.
Hey, it works. Okay, so up front, just a brief background on what RFC 6962 BIS is. It is the second version of the certificate transparency protocol that iterates on 6962, which has been deployed for some time now. But in the final stage of definition of 6962 BIS, we have received a discuss item saying that it violates BCP 190. And so TLDR, we're asking for an exception to complying with section 2.3 of BCP 190 for 6962 BIS. And so we'll get into that here in just a sec. Some quick background. The purpose of certificate transparency is to publicly log all issued TLS certificates at the point of issuance for the most part, such that anyone can audit them and we can detect misissuance. The 6962 is the original one, and BIS is draft 32 is the current version of V2. And certificate transparency enforcing user agents, like a browser, for example, require proof that a TLS certificate has been logged in one of these or several of these logs in order to successfully validate the certificate. And the behavior of logs is heavily dictated by existing user agent policies, such as Chromium CT policy or Apple CT policy. And this is sort of the gist of really what I want to get into here is that CT is an adversarial verifiable protocol that is specifically designed to limit the reliance on trusted third parties. And so the named use case here is reducing reliance in CAs, but one of the inherent designs of this was also to not sort of kick the trusted third party can down the road and then trust CT logs. And so we achieve verifiability through a set of, by limiting CT logs to a limited set of behaviors. And it's a non-goal of ours to add flexibility to these log operators in such a way that could be gamified to sort of counteract some of the overall goals of certificate transparency. And so getting kind of right into this, I want to talk about the approach that we're recommending here. And then following this, I have an analysis of alternatives so that we can really have that conversation. Draft 31 of 6962 BIS, before we tried to accommodate BCP 190 with the well-known language, basically specifies this, that the log server prefix, which is one of a set of log parameters that includes log key, maximum merge delay, a couple of the parameters for a CT log. is specified, and it may include a path as well as a server name and a port. These two entries here are just examples of two of the APIs that are defined, and it's log server /CT/v2/submit entry. And so to just sort of hone in on the point that log server has some flexibility into it, these are three real world examples of existing logs. We have a digicert log, which shows column/log. We have a Google log that is logs/Argon 2019, where that's the name of the log itself. And then Venafi, their one just comes straight off of the base as well. So to address, there was some discussion on Thread about alternatives to the existing approach, and one of them was .well known. But if you pull from the RFC 5785, it says in section 1.1 that well-knowns are not intended for the general information retrieval or establishment of large URI namespaces on the web. And additionally, that was discussed on the thread, was that the well-known space is often restricted by service providers, which would limit certain deployment scenarios for log operators unless they got exceptions.
So if I may just quickly, and I'm speaking only as an individual up here, RFC 5785 has been obsoleted by a document that was specifically designed to remove this.
Oh, okay, sorry. I quoted.
I sent you an email on this. Apparently you didn't get it in time. I apologize.
Apologies, sorry, yeah.
Thanks.
One of the other ones that was heavily debated was the use of directories. But as I mentioned in one of the previous slides, we're keen on reducing the ability for log operators to hide misbehaviors through shenanigans. And so we don't want to give log operators the ability to sort of hide misissuance, if you will, through behaviors like constantly changing the directories. And so one of the goals is to fix the log operator behaviors in such a way that the behavior is well-defined and is verifiable. And in addition to this, there is already a set of log parameters that are sent down, which is, as I mentioned, hash algorithm, key ID, maximum merge delay, and currently the log server parameter, and a switch to directory would basically bifurcate these and add additional complexity here. And sorry, on the and a move to directory would have a introduce ambiguity around how often it should be refreshed, what is stale, what is fresh. And lastly, we considered URL templates, but currently this would require a significant increase in client-side implementation logic that is otherwise completely unrequired by the protocol. We have deployed 6962, the original version of CT, by certificate authorities, log operators, and multiple user agents, and none of the members of the ecosystem have expressed concerns with this specification. The increased implementation logic would also discourage diverse implementation of CT auditors, which are not always implemented by very large, well-funded tech companies like user agents, and we would like to encourage that broad implementation. And sort of lastly on this point, in a real-world scenario using URL templates, it would likely ossify. The entire ecosystem would ossify on the exact same structure we currently have, and we pointed to an example of where this actually happened with Weirds, with some discussion on that point. And this is just some backup, and this was scraped together by some people in the trans working group about various protocols, either in IETF or not, that don't follow this section of BCP 190. So I'd like to open for discussion on this point.
Okay, okay, Jacob, you got the floor.
Hi, am I coming through loud and clear?
Yeah.
Great. So my perspective on this, I am both a domain owner, which is kind of the primary concern of BCP 190, is don't put restrictions on domain owners. I operate a CT log. I'm also a consumer of CT logs, so I use this as a client. And I've also just worked a lot with HTTP APIs in the past. And so, from my perspective, the CT API as it's defined in 6962 is fine. It's been zero burden. And I think it makes a lot of sense to keep the same approach for V2. And just generally speaking, I think, I spent some time looking at the history of the discussion on BCP 190, which some of you probably remember started as draft Nottingham, get off my lawn. And I looked at some of the motivating examples early on. And there's three main things it prohibits. Don't add query parameters to arbitrary URLs. And the motivating example for this at the time was the URI signing draft, where you would take a URL that existed and append some query parameters with like a signature and so on. And that does this transformation that is invasive on existing URLs. So fine. I think that's totally reasonable. There's also the issue of collisions with paths. So BCP 190 says, don't specify an absolute path on a server. Somebody might be running something else there. And then the third thing, which is section 2.3, which is what we're talking about here, says that even if the server operator specifies a prefix out of band, like in these examples, /log or /logs Argon 2019, even then, you, as a protocol designer, you can't say, within that space, it'll be /ct/v2/submit entry. You have to indirect that through some other mechanism. And the other perspective I have on this is as a co-author of ACME, which ran into a similar objection early on. And we decided, we actually went through also a couple of rounds of iteration on, okay, how do we work around this thing? The first iteration was bad. We used link headers that didn't actually adequately model our space. We needed to change kind of mid-protocol. And we adopted the directory structure. Actually, during this process for 6962 bis, I suggested, let's just try directories again. And when Rob tried to add that to the draft, he realized there's actually some bugs in this. And he filed an errata against ACME that unfortunately, due to deployed behavior, we can't now fix. So, basically what I've seen is adding these unnecessary indirections produces bugs. It has like a lot of potential to produce bugs. And at the same time, the normal and accepted practice for specifying APIs that use HTTP is you have a prefix, and under that prefix, you have a number of paths that do certain things. You document
Jake, interrupt you, but we're out of time and we have other people in line. Can you wrap up really quick?
That's it. That's all I wanted to say. Thank you.
Thank you. And then the lines are frozen after the people that are in it, and we're technically out of time so everyone be fast.
Victor Vasiliev, I will be very fast. Nobody should ever be forced to follow BCP 190 section 2.3 if it doesn't make sense in context. I personally believe that it has been shown that slides with all of the protocols which people use in real world extremely successfully, like the GATE protocol, which do not follow it and do just fine. So I do not believe we should add extra complexity just to satisfy those requirements.
Okay, so hold on, would you mind? We've got somebody, Andrew, in the queue, and
Sure.
Okay, Andrew, you've got the floor.
Hi, yes, I'm Andrew Ayer, and I wanted to add my perspective as a certificate transparency log auditor. And I wanted to underscore that certificate transparency isn't a normal protocol, it's a verifiable protocol. And that means that the protocol needs to facilitate auditing and the discovery of misbehavior. And one of the things we've learned since the deployment of version 1 of certificate transparency is that it's really hard to anticipate all the ways that a log could misbehave. And this makes it really hard to write an auditor that's secure. And I think this, and the antidote to this, which I think is also a problem that would apply to other verifiable protocols, is to make the protocol as rigid as possible, because that reduces the number of ways that a log could misbehave. So while it may be appropriate for a non-verifiable protocol to have to follow BCP 190, I think that in the case of verifiable protocols, it's important for the security of those protocols to give the protocol designers flexibility in locking down the protocol to make it more verifiable. And that's all I have to say. Thanks.
Colin Jennings, I mean, it's clear that the best current practice of every single deployed API service in the real world today is to use prefixes exactly like you use them here. This 190 is just out of whack, and we should deprecate BCP 190.
Okay. Okay. So we're out of time. Take it to the list.
Sorry, no, if I can be more concrete, we do want to have a side meeting on this. So if, this week, there's not one scheduled yet because it wasn't clear that the people who cared about this were necessarily paying attention. And so we want to make certain that after this discussion, we got a meeting together where the interested parties were able to get together in a room and talk about this. So what I'd like to see is the people who have an interest in this topic coordinate amongst themselves on the ART mailing list to find a time where they can get together in one of the side meeting rooms this week. I would like to see this as the beginning of the conversation. We clearly did not reach any conclusions. We ran out of time.
Okay,
Thank you.
Anyone have the other blue sheet? Has anyone not signed a blue sheet?